Hi everyone, and welcome to my garage. Yes, it's a special place. And the reason why I am shooting this video here today is because I would like to install this Wyze security camera here. And unfortunately, I don't have a lot of power outlets in my garage, and I don't want to have wires visible everywhere. The garage is pretty clean, and I would like to keep it that way as much as possible. So I'm going to do it a bit differently and in a way which is a bit unusual, which is why I thought it would deserve a special video. To be more specific, I have this doorbell transformer right here, and many of you have a similar doorbell transformer, I'm sure. And I'm going to connect the Wyze camera to it. So I'm going to show you how to do it safely, and I'm going to show you what you need to do it. Stay with me. One of the first things we need to do is to check the output voltage of the transformer, because this will tell us what kind of power supply we need to power the Wyze camera, because the Wyze camera needs 5 volt DC, and a transformer like that outputs a voltage which is AC. So there will need to be something to be done here. So I'm going to use my old multimeter to do that. For video purposes, I'm going to tie it to the transformer, just like that. And just like this. So I set it to AC 200 volts, which would be plenty to give me a good reading. So the output voltage I see on the transformer is 16 volts. It's a pretty common voltage, and it's pretty convenient, to be honest, because it's not super high, so it should be relatively easy to find a matching power supply. The next step is to see if we can have some specifications about that transformer. Specifically, we need to make sure that it has enough power available to supply the Wyze camera. The Wyze camera uses 5 watts maximum as per its labeling, and I have to make sure that this transformer has enough capacity to supply not only the existing loads, which I have to measure, but also the Wyze camera on top of everything else. So the first thing I'm going to do now is to try to take a look at the transformer and see if there is any marking on it. On the transformer, it's written 60 volts, 10 VA, and it doesn't give me a lot of margin, because if the camera uses 5 watts, in DC it's 5 VA essentially, I hope that what we currently have uses less than 5 VA. Currently the transformer supplies 4 incandescent bulbs, which are used outside of my house to show the apartment or the house number. So because they are incandescent light bulbs, it's possible that they use quite a bit of power. So it's going to be interesting if this transformer has enough capacity to supply both the light bulbs and also the Wyze camera. So what I'm going to do is I'm going to disconnect one of the terminals of the transformer and use my multimeter in current mode, AC current mode, and I will connect it in series between the transformer and the load in order to measure how much current is actually used right now by the incandescent light bulbs. Before proceeding, obviously I assume that you have the necessary knowledge to do this if you choose to reproduce it. If you don't, please call a qualified professional. Obviously don't go after me. If there is any problem, you could break something, or worse, you could have an accident, so be careful please. With that being said, let's do the measurement. I have now disconnected one of the terminals of the wires. There are 2 wires because there are 2 sets of 2 light bulbs from the terminal. So I'm simply going to connect my multimeter in series with everything and see what type of current we have. I expect the current to be relatively low, and this is low voltage, which is why I can do that way. But if it was using higher power or higher voltages, obviously the connection techniques you need to use need to be a bit more robust. But for low power like that, it should be fine. So what we read on the multimeter is 0.48, so that's 480 milliamps. Considering the output of the transformer is 16 volts, it means that the light bulbs are currently using 8 VA. So unfortunately, it's very likely that I don't have enough capacity in that transformer to power both the Wyze camera and the light bulbs. However, it's possible I still have enough capacity in practice, because the power they write on the Wyze camera is the worst case power, and it's very possible that in fact the Wyze camera uses less. So I could still connect it. I'm going to connect the wires back and think a little bit about it, because obviously it's not a clear case where you have enough power and it's super easy to connect. So yeah, I have to think about it a little bit. Okay, I have reconnected the transformer to the light bulbs. I can now get out of the ladder safely, and I'll talk to you in a bit. The first thing I need to do is collect all the pieces and check if everything fits together. Obviously, we have the main piece, the Wyze camera. And what I did is, because the Wyze camera takes its power from the micro USB port on the back, I've ordered some micro USB connectors. So I got these from AliExpress. They are very cheap, but they are also sold in the US by Adafruit, which I'm also going to use as a reference for the pinout. The way they come is that you have a shell and an internal layer. So the connector itself is this. You see that you have 2 pins here on this side and 3 pins on this side. So some of these pins are ground and 5 volts. And then you have an enclosure. So the enclosure is simply snaps together. You put the connector inside, assuming you have soldered all the wires, and then you snap it together just like that. Super easy. The issue is that once the enclosure is snapped together like that, it doesn't fit in the Wyze camera, because the hole on the back of the camera is simply too small to accommodate the enclosure of the USB connector. So what I'm going to do is I'm simply not going to use the enclosure. I'm simply going to solder the wires to the connector, just 2 wires for plus and the ground, the plus 5 volt and ground, and I'm simply going to connect it there. However, in order to provide some mechanical stability and also some electrical insulation, I'm going to cover the connections with epoxy glue. And it's going to provide electrical insulation and also some mechanical stability. It will ensure that if I ever pull the wires from the camera, the strength will be provided by the epoxy attaching the wires to the frame of the connector and not just the soldering to the pins here. So it looks like we have a plan. Oh, and also, of course, I need a power supply. The transformer for my doorbell is actually using it's actually AC, so I need an AC to DC converter. So this one can take between 7 and 35 volts AC. So as we saw, it's compatible with the output of my transformer, and the output is 5 volts up to 3 amp. The Wyze camera comes with a power adapter, and this one, it says 5 volts, 1 amp. And if we look on the bottom of the camera, we can see that it says 5 volts, 1 amp too. So it's pretty much overkill, because this can supply up to 3 amps, but it's more than enough, and that's exactly what we need. So now it looks like we have a plan. We have the power supply, the connector, and the camera. So now what I'm going to do is simply solder the wires from the power supply to the USB connector here. My lab is currently temporary and I don't have all the soldering equipment which I normally have, so I have no way to hold the micro USB connector while I'm doing the soldering. So I'm going to use this cheap power bank case. It doesn't have batteries inside, so it's going to be very convenient to hold the micro USB connector in place, just like that. What I'm going to do first is tin the connector, then solder the wires, and then I will go back to my garage and apply the epoxy glue. So the power supply wires are the ones located on each side. So that's the ones I'm going to tin first. Here's one, and here's two. And now I'm simply going to attach the wires to the USB connector. What you see is that the yellow wire is the positive output and the black wire is the negative output. This is expected, but it's always good to take a look on what's written on the enclosure just in case, because sometimes they invert it. So the wires are already tinned, that's good. And the ground connection is on, let me see here. The ground connector is here, so it's on the left. So the ground being on the left, so I'm tinning again the wires because it adds some flux into the solder, and also I don't know what kind of solders they used in the factory when they tin the wire. So at least if I use my own solder, I'm sure that the melting point of the solder is something I can control. Whereas if I use their own solder, I have no idea what's the melting point of their solder. Okay. So we have soldered the minus, and now we're going to do the positive side. You definitely don't want to overheat the connector because the frame is plastic, but you also want to make sure that the joint is good. So it's definitely a balance that you have to find between heating too much and heating not enough. Okay, it looks like a good solder joint now. Let's check, let's take a look. Yeah, it looks good, it looks perfect. So what I'm going to do now is actually connect the input of the power supply module to my lab power supply because it can accept DC too, so it's fine because there's a rectifier inside, so it can accept both AC and DC. So I'm going to connect an DC input and just check that everything is fine at the output. So let's do that. It's a quick test, so I don't bother taking any connectors or anything. It's not the best connection, but to do a quick test like that, it's perfectly fine. For the voltage, they accept between 8 and 52 volts, so let's go to 24 volts. And for the current limit, I'm going to enter maybe 300 milliamp. Not too low because I don't want the power supply to trip, but not too high because if there's a problem, I want to be able to turn it off quickly. Okay, so let's turn it on. Good. So we have 20 volts at the output of the power supply, and the quiescent current is 1.5 milliamp. This is expected. It's a reasonable quiescent current range. It's not the best, but it's not worse. It's not the worst. I've seen something like 5 milliamps before, or even 10 milliamps. So it's good. What we're going to do now is measure the output just to make sure it's 5 volts, that the polarity is not reversed or anything like that. So I'm going to grab the probes of my multimeter. Okay, 5.29 volts. So that's good. It's a bit higher than 5 volts, but it's totally within specs. I believe that the spec for USB is between, if I'm not mistaken, between 4.5 and 5.5, or maybe between 4.75 to 5.25, but that's definitely good enough. In general, it's acceptable to have a slightly higher voltage because it gives some margin if you have some voltage drop within the connection. In fact, you have some cell phones which are using a 5.2 volt power supply for that reason. So I don't expect any issue with that voltage, even if it's a bit higher than what it should be. So it looks like everything is fine. I'm now going to connect a cheap load to this USB connector. Why a cheap load? Because I want to make sure that the polarity is correct. I don't want to burn anything valuable. So yeah, I'm going to find something cheap and which I don't really care if there's a problem, because I mean, I don't have a test jig to make sure, for instance, that there is no short circuit between the connectors internally or that the connections are good. I based the connection on what I found on internet for this connector, but you know, it could be wrong, so it's better to test. I could technically, the proper way to do this would be to find a micro USB female breakout board, connect it to it, and then check the connections, but I don't have that on hand, so I'm just going to use something else to test. So I've put some batteries in this enclosure, and I'm going to connect it and see what happens. It looks like it's charging. The charge current seems to be approximately 240 milliamps. The LEDs are indicating that it's charging. Everything looks to be fine. So it looks like my contraption worked. So now the next step is to provide some mechanical protection by applying some epoxy glue to the outside of the connector, all around it, to maintain the wires in place and provide some electrical insulation. I need to be careful because if the epoxy layer I put is too big, then it's not going to fit inside the space provided for the connector on the camera. So it needs to be relatively thin. I don't have a lot of margin here, so I need to be careful with that. But otherwise, it's a pretty simple process. So I have my little contraption here, my power supply, and I used a piece of plastic and a piece of cardboard in order to mix my epoxy. Pretty simple stuff, pretty cheap epoxy. I'm taking the cap, opening it now, just like that. I try to put the bubbles at the top, just to try to remove the air and to make sure that I don't have more air on one side than the other one, because I'm trying to do a 50% mix. Pressing slightly. Okay, not too bad. And now I have the epoxy exactly at the same level on each side, so it means my mix is going to be close to 50-50. I put a little bit of epoxy, just like that. And now I put the cap back in. Put some air so that the cap has some space for it. And I press it in, and it should go in without any problem. Yes, it does. I usually use another piece of cardboard just to mix the epoxy. You need to make sure that the epoxy is very well mixed, because if it's not, you're going to have curing issues. It might either not cure at all, or it might have reduced strength, or it could also stay tacky because the chemical reaction is not going to polymerize properly. So yeah, just take your time, not too much time because you only have 5 minutes. This is quick epoxy, but yeah, you just need to make sure it's fine. Okay, I think it should be good now. Okay, let's do it. So remember, I need not to put too much epoxy, just a little bit, just to provide electrical insulation. Just like that, on one side, and then on the other side. I need to make sure there is some epoxy on the wires themselves. Just like that. And finally, just a little bit of epoxy on the plastic enclosure itself, but I need to make absolutely sure it doesn't go on the connector. If it does, I have to start all over again. Okay, I think it looks good now. What I'm going to do now is I'm going to put heat shrink on top of everything. When I'm going to use heat to shrink the heat shrink, it's going to make the epoxy much more liquid. So I have to be careful that it doesn't go everywhere. And I want to do it before the epoxy cures, because if I do it after, the tubing won't be glued to the epoxy, and I want everything to be glued. So I just put it like here. And now I'm going to use a lighter to shrink it. The size of the heat shrink tubing is a bit bigger than what I should probably have used, but it's still okay for this application. It's not super critical. So while the epoxy is still uncured, I need to make sure everything is straight, because once it's cured, goodbye. I cannot do any modification anymore. It looks pretty good, like that. The good thing now is that the heat from the lighter is going to make the curing process of the epoxy a bit faster. It's not going to make it immediate, but instead of taking maybe 24 hours to cure, maybe it will be a bit faster. So it's always a good thing. Yeah. So now we're going to wait a little bit and then we can proceed with the installation. But in the meantime, I'm going to do some testing just to make sure that electrically everything is fine. I'm probably going to do that off camera. So after washing my hands and waiting for some time for the epoxy to cure, now is the moment of truth. Does it fit? Yes, it absolutely fits perfectly. There's some play, some room to spare, that's good. So what I want to do now is connect this assembly to the doorbell transformer because I want to see how much power it uses overall, just for information. So we're going to do that now together. So I'm going to disconnect the light bulbs and connect only the camera to the transformer. So my multimeter is now set to AC current mode, and I'm also going to connect the second terminal to the transformer through the multimeter just to see how much power is actually being used by the camera. It's not going to give me an absolute answer because the current use of the camera varies depending on what it's doing. For instance, if its infrared LEDs are on or off, but it should still give me an idea of approximately how much power is being used. 50 milliamps for now. 100 milliamps, definitely not much. I'm going to put it against the wall so that its infrared LEDs turn on. And I'm going to wait for a bit for the camera to initialize because it's taking some time. A 100 milliamps, still not much, 90 milliamps. And it seems to be stuck at 90 milliamps. 100 milliamps, between 90 and 100. And if I put it toward me, it moves to 80 milliamps. So that's the difference because of the infrared LEDs. Yeah. So it doesn't use a lot of power. It's only using approximately 100 milliamp at 16 volts. So that's approximately 1.6 volt amps or 1.6 watts, approximately. So that's good news because it tells me that, in fact, I do have enough capacity on that transformer in practice. In theory, I don't. In practice, I do. Obviously, I'm taking a risk here. I'm taking the risk to overload that transformer. It's a personal decision. I'm doing it because I'm confident it's fine, but I don't recommend you do that, or if you do, it's your decision, and just be aware that you're taking the risk of overheating your transformer, burning its fuse, or things like that. So yeah, just be aware of the risk. But that's good news, good to know. So what I'm going to do now is actually connect everything together because I have everything which is needed. I'm just going to reconnect the light bulbs, connect the second wire of the camera, and everything should be working fine. I'm going to do that now. And I'm done. Everything is working fine. Everything is connected together. The transformer is not overheating or anything. It's thermally protected anyway, so it should be safe. I adjusted the angle of view of the camera, so I have a nice view of my entire garage. I see the door, I see inside, and I see every side of it. So I'm pretty happy with this little installation. I'm going to install a stronger transformer someday, but based on my measurements and what I see here, and I let it run for a while, it's really not hot at all. So I'm confident it will be fine at least for a few weeks until I have time to install a bigger transformer. So thank you for following this video. I hope it was helpful to you if you want to do something like that at least. And see you next time. Bye.